This video is part 2 of chapter 47, parametric equations and surface area. And here we're going to look at example 269. Example 269 has 3 parts to it. And so we're going to find the equation of a tangent line, we're going to find an arc length, and we're going to find the surface area. And so the parametric equations were given. X is 2/3 t cubed, y is t squared plus 1, and t ranges from 0 to 2 square root of 2, which is also the square root of 8. Now, because this has 3 parts to it, and we're going to reuse some of our calculations, I'm just going to do some preliminary calculations before we even start part A. So we have the derivative of x with respect to t is simply 2t squared. The derivative of y with respect to t is 2t. And the derivative of y with respect to x, the dy dx, this is y prime divided by x prime, which is 1 divided by t. And then we will simplify the square root of x prime squared plus y prime squared, because we'll use this expression in parts b and c. And so this is just 4t to the 4th plus 4t squared. We factor out a 4t squared out of the square root. It comes out as 2t. So we have 2t times the square root of the quantity t squared plus 1. Part A is to find the equation of the tangent line at the point when t is square root of 3. Well, to find the equation of a line, we need an x-coordinate, a y-coordinate, and a slope. So to find the x-coordinate, we substitute square root of 3 in for t right here. To find the y-coordinate, we substitute square root of 3 for t in the y equation. So we have x is 2 square root of 3 and y is 4. And dy dx is 1 divided by square root of 3. So we have an x-coordinate, a y-coordinate, and a slope. So to find the equation of the line, we have y minus the y-coordinate is equal to the slope multiplied by x minus the x-coordinate. And so there's part A. Part B is finding an arc length. So that means we're just going to integrate this expression. So we integrate from 0 to 2 square root of 2 of 2t times the square root of t squared plus 1. Note that the derivative of t squared plus 1 is 2t, so this is a very straightforward substitution. Since it's such a straightforward substitution, we can also just do this by finding an antiderivative. And so this expression can be rewritten as t squared plus 1 to the 1/2 power. So we increase the exponent by 1, multiply by 2/3. Take this derivative to check our answer. 3/2 times 2/3 is 1. We have t squared plus 1. Decrease the exponent by 1. Then multiply by the derivative of t squared plus 1, which is 2t. So we calculate this derivative. We get this expression. We'll substitute in our limits of integration and subtract. So now is a good time to recall that this is a square root of 8, because then 2 times square root of 2 squared is simply 8. So we substitute square root of 8 in for t, we substitute 0 in for t, and we subtract. And it simplifies to 52/3. And finally, the last thing we're going to do is find the surface area that we get by revolving this region around the x-axis. So we have 2 pi, we have y, and then we have our derivative of x squared plus derivative of y squared under the square root. So this part right here, we've already calculated this thing here. So now we multiply by y, and this simplifies nicely. So the t squared plus 1 times the square root of t squared plus 1 is simply t squared plus 1 to the 3/2 power. We have our 2t, and again the derivative of t squared plus 1 is 2t, so that again makes a fairly straightforward substitution. So it's just a matter of finding an antiderivative. We have increased the exponent by 1 to get 5/2. We multiply by our 2/5. Calculate the derivative of this expression to make sure we get this. So we have 5/2 times 2/5 is 1. Then we have t squared plus 1, decrease the exponent by 1, multiply by the derivative of t squared plus 1, which is 2t. So this is in fact an antiderivative. We'll substitute 2 square root of 2 in for t. Again, remembering that this is square root of 8, so this is just 8 plus 1 right here. So what we did here is we factored out a 2/5 to get our 4 pi over 5, and then we substituted square root of 8, substituted 0. When we substituted square root of 8, we have 343. When we substitute 0, we have 1. So we just subtract and simplify.